CloudDB, shaping your new normal.
All right, my internet's playing a little bit of games at the moment here, but no problem. And hi, everyone. Good morning, good afternoon, good evening, depending where you are around the world. Welcome to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal session, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you will be able to have access to all replays until December 30 through the platform. I would like to say thanks to all Oracle user group and Java user groups, all 16 of them, that made this event possible, and also to our sponsors, Oracle Groundbreakers and your main sponsor, CloudDB. Now for today's session, Build High-Performance Applications in Node.js for Oracle Database by Christopher Jones and Sharad Chandran. Please feel free to post questions at any time by using the chat window or the right lower corner of your screen. Just where you see the chat word in the right, you see like a circle with flags. If English is not your first language, you can press that. You can then enter the chat question on your original language, and the system will translate it for English. Also, if you have any issues during the transmission, please feel free to use the same chat window to let me know, and I will try to help you the best I can. Now, without any further ado, I want to leave you with this amazing session by Christopher Jones and Sharad Chandran. All right.
Well, thank you, Francisco, and organizers of the conference. It's a huge conference, fantastic effort to get it all together. My name is Christopher Jones. I'm here with my colleague, Sharad Chandran. We are product managers in the Oracle Database Group, looking after a number of database access APIs for the Oracle language, the Oracle database. I might just take this moment and actually cancel my video just to give you a bit more screen real estate so you don't have to squint some of it. Morning, and Sharad, I guess if you do the same, then we'll give you the maximum real estate. So we are product managers, so we get to deal with all of the fun things, incoming, outbound questions, dealing with specifications, working with code, working with developers, speaking to customers, etc., etc. Some of you may have seen our presentation last week, and this goes into a bit more of a deeper dive and covers a few new topics as well. But just while we're waiting for the last couple of people to join, have one warm-up slide. Node Oracle DB is the module for connecting Node.js applications, whether or not they're written in standard JavaScript or in TypeScript, connecting those to Oracle Database. It's open source, it's installable via NPM. It is a thick client installer, you might have seen from the previous stack, so you need to get the Oracle Instant Client libraries. That's a straight download. There's no click-through and unzip on many platforms, or on Linux, it could just be an RPM install. One little snippet of code there. We'll have more snippets, and I'll actually have a live demo later. Standard get connection, execute and close connection process, just like any kind of programming language. For these demos, I do tend to have the password hard-coded, but obviously you might not do that. And you might be using external authentication or some other kind of wallet to avoid leaking credentials. So the topics today are speaking about reliable connections, big topic, lots of interest there. Efficient data handling, so some good tips there. And we're going to talk about some advanced queuing and continuous query notification features, which can be really useful, particularly in things like web services. And we're going to finish up with some talks on, some slides on availability. So under the covers, thick client, as I mentioned, users on the left, they may be using GraphQL queries, REST queries, whatever else they have, a web app or something like that. Node Oracle DB converts these into calls down to the Oracle interface, call interface, and they go across SQLNet, the OracleNet layer to the database. They can be in the cloud, on-premise, anywhere you like. So Oracle Client libraries themselves provide a lot of the functionality, and it's tried, tested, it's used in all sorts of places, other drivers, as you saw, used internally in Oracle, actually even used on the database tier, so it's a very solid layer, has all those performance, high availability features that you like. Therefore, it lets Node Oracle DB Node OracleDB be quite a thin layer, efficient layer. And OracleNet, not a separate product, it's just how the connection to the database happens, provides a lot of stuff like the failover, encryption, and other options that you can configure with the SQLnet .rf files. So you might not see a lot of encryption in the Node OracleDB manual because it's actually somebody else's problem that's in the SQLnet manuals. So just going on to connections, so we want to spend a little bit of time on this hot topic. People always want reliable connections. That little snippet I showed before had a standalone connection. Obviously, in a multi-user application, you want to use a pool. So a pool provides an available set of resources already established to the database. So there's no re-authentication needed. There's no connecting across the network, waking up the OracleNet listener, allocating memory, etc. You create this pool at startup. Pools available can grow or shrink. Most applications will use this. If you have a lot of connections which do a small amount of work and then release a connection. And sometimes you might use a pool if you have a small number of connections that are often idle. And the pool offers some high availability features, and that's why you might use it in that case. Also, the pools support a lot of Oracle's more advanced features. Talk a little bit about some of those. The DRCP, actually not going to talk about. Application continuity we'll cover a little bit, but the pool handles those things automatically for you. So pretty much you'd want to be using a pool. So as I mentioned, create the pool at initialization. You get standard pool parameters, min, max. So this lets the pool start with an initial size, grow to a certain size to handle a particular load. Increment is how rapidly it grows if it needs to grow. Pool timeout lets it shrink back down if connections aren't being used. Runtime, you should get a connection, and most importantly, you release the connection. So from the application point of view, it's closing connection. Internally, of course, that's releasing it back to the pool for somebody else to use. And at termination, you want to shut down the pool cleanly, and we have a grace period there, which I've set to 10 seconds in this example, and that lets people already accessing connections, using connections, that gives them 10 seconds to continue using those connections, but stops anybody else getting a connection. They'll get an immediate error back when they try and do a get connection call. So it just lets a drain time have some effect. If you set a 0 drain time, then it's just immediate, gets closed. But that lets the connections be closed nicely on the database side, and lets the application drain cleanly. So we also have some resiliency built in. What happens here in this case, on this slide, you've got 4 users, they're all executing 4 SQL statements. They've checked out, as we call it, 4 connections from the pool, and pool therefore is maxed out in this example. Get 4 more users, they can't get a connection because those 4 connections are in use. They get put in a queue temporarily. And so they're just sitting there waiting. They've got a pool.get connection call, and that's just sitting there hanging, waiting for one of those original users to free up a connection, which then can be allocated to one of these new users. Queue timeout 60 seconds by default. You can change that at pool configuration time or later with a reconfigure. So this lets the pool and the app be more resilient to sudden connection spikes. Yes, a few users may wait a couple of milliseconds there before they can get a connection, but it means that they don't get an immediate error, or they don't, in fact, with a timeout, they don't get blocked forever. So there's a parameter queue timeout. If it gets exceeded, they will get an error back from that get connection call if they've been waiting too long. And of course, when the pool gets really slammed, if you have a denial of service, accidental or deliberate, there is an upper limit to that queue length with the queue max parameter. And then anybody else beyond that limit, when they do get connection, they'll immediately get this NJS 076 error message back. Anybody still in the queue is going to be subject to the timeout I showed on the previous slide. The limit here is 500. This is great for lots of apps. Of course, in production, you may be using something like a load balancer, which handles spikes anyway. So we have some tuning. So you can tune the pool. So when you create the pool, you can enable statistics. Otherwise, we don't record them by default. And then you have a get statistics, or if you want to display directly to the console for quick ease of use, a log statistics method, which displays with a console.log. We have a pool reconfigure option, and you can actually reconfigure sizes and many of the options there when you can that you could have created the pool with initially. And one of them, as I show here, is just to enable statistics, or you can disable them if you have a specific point of time you want to capture data. So here's an example of the log statistics, just printing output. And if you look at the top, I'm running the Apache benchmark tool, 1,000 requests and a concurrency of 10, so 10 at a time coming into my little simple web app. It's pretty quick. And we can see here that there are 995 of those get connection calls actually got queued, so they couldn't get a connection immediately. The numbers, by the way, may not add up precisely because the demo opens one connection at a time. You can see then the average time in the queue, 5 milliseconds. This was to my little local database, so it's relatively quick. The app just does one query, so it's quite possible for things to not look perhaps as clean as they are, and you can see that a little later when I show you the next stats after we've done some tuning. The obvious thing here is the pool is too small. I'm trying to do 10 things at a time, but I only have 4 connections available in the pool. So Node.js has concept of worker threads. So this is the scenario we have, we could bump up pool max to be 10. That would cater for our 10 users that we send, 10 requests we send. But actually, because Node.js only has 4 worker threads to handle work, it can still only actually do 4 things on 4 connections at a time, 1 thing on 4 connections at a time. Those threads will block. They'll wait for the database responses to come back before threads can be used by somebody else. So the solution is to increase the thread pool size before you start the application. And you can get away sometimes with doing this inside the application on Linux platforms, but you have to make sure you set this variable before the thread pool starts. It has to be very early on. It's a little bit error prone, and you can easily not get it set correctly. And on Windows, you always have to set it before Node.js starts. So you can use a start script here. You can do a set on Windows, export on Linux to bump up the thread pool size. You may want a couple of extra threads because you may be doing non-database work. If you create a couple of pools or using standalone connections, the same thing applies. You want the number of threads to be greater than the number of connections total in the whole process. Oh, and one extra tip is that our real-world performance team like to have fixed pool sizes because they know when database slams happen early in the morning, then database has to allocate resources, do more work to create connections just at a time everybody else is actually trying to do work on the database. So it kind of gets double hit. So they like seeing a fixed pool size, and therefore you don't get that connection slam. You may also consider a non-zero pool increment. In recent versions of Oracle, that's okay. Older versions, you get an error unless you set it to be 0. I think it was like 12 or 18C or something. We freed this up. And this is to cater and recover from a catastrophic case if all of the connections get closed for some other reason and they have to be recreated. Otherwise, a pool increment of 0 actually translates to a 1. So there'll be a sort of incremental growth 1 by 1 by 1, adding connections to the pool as they're required. So there could be a little delay for everybody. So fixed pools don't suit every use case. You may have different apps running on the same system. You may want them to grow and shrink at different times. But if you've got a fairly stable system, this is our best practice recommendation. And there's another way you could stop database slams happening, connection storms, and you can go and configure on the database side some of the SQLnet parameters to limit the growth rate. That will obviously, of course, cause your users who want to have connections to be delayed in their GET connection requests. So we've done a little bit of tuning. Here's the same scenario, 1,000 requests, concurrency of 10. On the right, you can see we've changed our pool max to be 10, and we bumped up our UV thread pool size. And on the left this time, we still got some requests queued. That's because I'm on the fast system. We're running at the limit of exactly 10 connections available. I'm trying to do things 10 concurrently, and there may be a bit of timing going on there. But now, number of requests queued has dropped considerably from the 995, and the average time has dropped from 5 milliseconds to 1 in the queue. So fewer people getting queued for a shorter amount of time. So those are the best practice recommendations. Fix pool size, bump up the thread pool size. And actually, Sharad, why don't I throw to you? If you want to unmute yourself, why don't you talk about round trips?
Yeah, can you hear me?
Yes,
Chris?
Go ahead, Sharad.
Okay, thank you. So thank you for that, Chris. So in addition to using the pool statistics and tuning the threads, another general tuning goal is to reduce the round trips between the client and the server. So this typically helps in faster app execution and efficient usage of DB resources. Let's now assume that you have tuned the application architecture and you have tuned the SQL. So how can you further reduce the round trips on the application side? Well, there are a few tricks. You can use client result caching on the application side. You may want to reduce the number of rollbacks or commits. It is advisable to commit at the end of all the SQL statements that you may have in your application. It is always preferable to have a PL SQL statement block instead of multiple SQL statements. And you also may want to avoid as much explicit ping functions as much as possible. Moving on to the next slide. Another tip is you may want to reduce the round trips at connection. So typically, developers will want to set the session state, such as date formats or languages, after they get the connection. However, this is another round trip, and you do not want to do this. You can set the round trip along with the connection. This is especially useful in pools with multiple connections. How do you do that? You have something called a session callback. So this is an attribute which can be set with the create pool function that you see over here. So the session callback is usually used to initialize the session state when you're creating the pool, rather than setting the session state in a separate DB call. How the session callback works is that the callback function is called only once when the pool selects a brand new unused application, and it is called just before the get connection function that you see. Chris, if you can do one more. Yeah, it is called just before the get connection function call returns. So in this callback session, if you can see, there are multiple settings that you are setting. There are multiple SQL statements that you are setting in one go. And when you execute it, and when you get the connection, you will be able to set all the state in one go. And this will reduce the number of round trips, and the session states are maintained across different sessions in the pool in an efficient manner and are not rolled back. So just one tip here: the session state is different from the transaction state, which does get rolled back when the connections are released back to the pool. So there are a lot of examples for setting the session state efficiently by this method in our Node Oracle DB GitHub page. So request you to check it out. As you can see in the earlier slide, the language was set immediately. So in this slide, we are just going to show an example microservice and see how it works with and without a callback. So without a callback, as you can see, you have, let's assume that you have 1,000 get connection calls, and you're setting the state using the alter session calls, and every time you have to set the state when you do the alter session calls. So totally there are 2,000 calls. But with a callback, even though you may have 1,000 get connection calls, you're only setting the state every time you use a brand new, never before used connection. So since there are 4 connections here, you're only calling for the session. You're only setting the session state 4 times. As you can see, the number of round trips, SQL calls, and therefore the round trips are effectively halved, and it gives much more efficient usage of the DB resources. So moving on, want to talk about fetching data. Now that we have talked about various ways to connect, let's look at how to work with data in Node Oracle DB. So there are 3 ways of getting rows of data. One is to fetch all the rows using the execute method. If you want to get batches of rows, you can use the result set attribute. And if you want to stream your rows, because the row may or may not be available at some point of time, you can use the query stream interface. Quickly moving on. So for all these 3 query methods, there are 2 parameters, two tuning parameters that you will definitely need to use to set the internal buffer size used for fetching rows. So these are the prefetch rows tuning parameter and the fetch array size tuning parameter. These tuning parameters will reduce the round trips, but they will also use use up more Node Oracle DB application memory. They do not affect the SQL optimizer on the database, and nor will they affect on how many rows or when the rows are returned to the application. They will simply tune the internal buffers in Node Oracle DB and can help improve the application performance and stability as required. Moving on to the next slide. So why do we have two settings? Well, we have two because of the way the internals of Node Oracle DB and the underlying Oracle client libraries work. They operate at different layers. They are relevant in different phases in an SQL query. So the prefetch size will work when we are in the execute phase of the query. Generally, when we are in the execute phase, or when we use the executes OCI underlying OCI execute statement, the query does not return any data. It just returns a success or a failure status message. So setting the prefetch rows will allow you to return some data along with the execute phase based on the prefetch value. So quick array fetch or fetch array size parameter works in the fetch phase of the query. So it is used to set the buffer size of the number of rows that needs to be fetched when you call the fetch statement. So quickly the next, when you call this fetch statement here, if you want to get more rows to complete the connection.execute call, you can set the array fetch accordingly. So moving on. This slide is showing a scenario where you're selecting a large amount of data and you would want to bump up the defaults here. Prefetch rows, you're setting the default size, but for fetch array size, you're bumping it up to 1000 from the default value of 100. So you should be tuning these in production scenarios based on your actual loads and network latencies. Let's take a look at another scenario. Here we are paging data. So for example, if you're using a web page, you want to fetch let's say 20 rows per page in this case. So if you want to optimize the number of round trips, you have to set the fetch array size equal to the number of rows per page, and the prefetch rows has to be set to number of rows plus 1. This will stop the extra round trip to detect the end of file marker. So just another tip here to reduce your round trips. So now this slide shows the effect of changing the prefetch rows and array size parameters for different number of rows returned by the whole query. So here we take the default scenario. As you can see, as the number of rows increases, the number of round trips increases as well. So let's say you do not know the number of rows, and if the number of rows are large, then it is better to tune the array size to a slightly higher value. When you tune it to 1000, the number of round trips, as you can see, dramatically reduces from 102 for the default version to a 12 over here, and the number of milliseconds also reduces. So finally, again, just wanted to touch on the paging scenario. So if you have a page of rows, it is always advisable to set the prefetch rows to 1 greater than the number of rows per page to achieve the optimum number of round trips and optimum usage of database resources, as you can see. Moving on. So far we have talked about fetching rows of text or number data, but what about large objects or lobs? Well, there is a global setting called fetcher string, which is commonly used for CLOB or character large objects, and another global setting called fetches buffer for blobs or binary large objects. So if you want to do it, if you want to set per column, if you want to fetch the data per column, then you can use the fetch info attribute along with Oracle DB.string for CLOBs. Similarly, you can use the fetch info attribute along with Oracle DB.buffer for blobs. So this tip will apply to this will apply to all the different types of fetches, the 3 methods that we discussed earlier, and this is typically used when your number of when the size of your lob is limited to 1 GB. So if the lob is greater than 1 GB, then you have to use the lob class to stream them. So which will again use lob locators. So we have talked about how to fetch data and do connections. Now let's look at how we can do data processing or data manipulations on the DB. So here I have a simple table with a key and a fruit column. Key column is not null here. So single row insert is quite easy. It is similar to how you fetch the data. Two things that you may want to note is that we are using binding here. So the bind variable will bind the values during runtime. Binding can improve scalability and it will ensure security. Especially, it is useful for avoiding SQL injection attacks. The second parameter that you see over here is auto commit. So auto commit is an efficient way to commit your data, and it is piggybacked along with the execute call. So it basically saves you one round trip as compared to an explicit connection.commit method. Since committing takes DB resources, it is better to use auto commit, but do not overuse auto commit. You ideally use auto commit with the last DML statement that is used in your app. Quickly moving on to the next slide. So what about a bunch of data or an array of data or higher volumes of data? You can execute one DML statement with multiple data values. You can do it two ways. You can use the execute function in a loop and then use the SQL statement on multiple data values in that loop, but that is very inefficient. The most efficient and most used function is the execute many function. So the execute many function basically binds a bunch of data to the to your SQL insert statement, along with a few options as well. Auto commit I've already explained in the earlier slide. You also have something called bind defs. Bind defs is optional, but it is recommended so that you can the Node Oracle DB can avoid having to scan all the input data to reallocate memory. So as you can see here, the binders have set the type of data, and they have also set the maximum size of the data in case of a string. So this will save a lot of this will create a lot of efficiency, and if you extrapolate this up to a very large data load, it can be very, very efficient. Next up, so what if you have noisy data in a large data set? In this case, batch errors is a very useful option to have here, especially for large data inserts. So if you remember, the key column was not null. But however, in this example, I deliberately introduced some invalid data here with null key values. So when we execute this, when we run the execute menu with batch errors, the application itself will throw error if there is an invalid data. One more thing to note is that while the valid rows are inserted, they are not committed to the database, even though you may have the auto commit option equal to true. So you have to go back, correct the error, and rerun the query again so that the data is both inserted and committed. Moving on. Now we are looking at some benchmarking between execute a function and execute many function. So this slide shows a time-based graph of using execute loop for n number of rows versus using execute many once for n rows. So this shows that execute many is much faster than looping over multiple execute functions. As you can see, for 10,000 rows, execute many is only taking 39 milliseconds, whereas for execute loop it takes almost 24 seconds. So this was recorded using a small record width on a local network, and you will see the benefit, even a higher benefit of using execute many when you have a remote database as well. So always use execute many. And with that, Chris, I'll throw it to you to explain about advanced queuing.
Thank you, Sharon. That was very informative. So advanced queuing is a way of message passing between applications. It's very full-featured in Oracle. It's producer-consumer messaging, great way to distribute workloads, and we often see this used in microservices. So the messages can be queued to multiple producers, different consumers can filter messages, messages can be transformed or propagated to queues in other databases. A queue itself is available in all editions of the database, has interfaces in many languages. That allows different kinds of applications to communicate together. So Node Oracle DB, we fit all of this functionality into a few classes. as we have on the screen. I don't think I need to go through that. But let's have a look at code. So you need a privilege, and you can refer to the Node OracleDB documentation for the background to this little particular demo and the setup which is needed, but assume you have that privilege or the system user. You can create a queue table. Here we're just using the old school behaviors, not the sharded queues. And obviously we create a queue and we actually have to start that queue. So now that queue is available to send messages and to receive messages from. So on queue statement would just be saying, hey, we need to get that queue so we know what it is, what we can do with it. And at the simplest, you can just pass a string, send a string down that and queue it. And here we're explicitly committing. So until we do the commit, that message isn't sent across to the queue itself. So that's great if you're trying to do a transaction, trying to insert some data into the database, or debit somebody's account, and you want to commit that debit and send a message at the same time. That all happens on that commit statement. So that's a great Oracle feature for queuing. Dequeuing is pretty similar. DQ1 method here. And the key thing is this is a raw queue, so then we have to access the attributes of that message, and we get the payload, and then we have to know that on this particular queue, these kinds of messages are strings, so we need to convert back to strings. We also have bulk OnQMany and DQMany calls, which can be really useful if you're trying to do a whole bunch of operations at a time. So there are options. Spoke about that commit before. What happens if you don't want that commit? You do want things to happen independently of the transaction state in your application. So you just set this onQ options visibility in this case to immediate. So as soon as I call that onQ1, the message will be sent and my current transaction won't be committed. Messages themselves also have some kinds of options. In this case, there's an expiration on this message, and that means that it can sit in the queue, and if nobody's listening for it, hasn't waited for it, hasn't pulled it off the queue for, in this case, 1 second, then the message will just disappear from the queue. So there's a whole bunch of functionality here. We make it all available in Node OracleDB. One little trick is if you're trying to update multiple options, you need to use this object assign method, so you can set multiple things at a time. So I was going to talk a little bit about continuous query notification, and I do have some slides, but I also have a quick demo, so we might just run that as a demo. Whoops, just gone back one slide. Get that ready for when I return. And so what I have here is a few scripts. Configuration just gets username, passwords from environment variables, and deletes from a table. No surprises there. Inserts into a table. Nothing fancy. You can also see the auto commit down here. And setup actually just creates a table. It's not that interesting to look at. So, this was the grant that I mentioned. So, sorry, this is a different grant, but for everything in Oracle, obviously you need to have some kind of privileges. So for change notification, we need the change notification grant, which I just allocated to myself. We need events mode to be true so that we know that we're listening for events. So we need to set that in our DB configuration with our username and password, and we create the connection, which is down here on the next line. So let me just recenter that screen. Yes, I am using Emacs and not something like VS Code. We don't need to go into whys or wherefores, but it's all the same stuff in the end. So this is the subscription. So obviously we've got a connection to the database and we're subscribing with a particular name. We just arbitrarily given a name. And there's a callback, which is a JavaScript function just lower down in the file. I'll show you in a minute. So what we're using here is what they call continuous query notification, as opposed to the older database change notification. And this is set here with this quality of service attribute. And this means that we're registering a query data set here with obviously a bind variable. So I'm interested in getting messages when data in this table, which is greater than, has a key greater than 100 is changed. If anything's inserted or deleted in that range, I want to know about it. I don't care about anything under 100. You can do what you like with that. Timeout means we're going to stop listening after 60 seconds. That's just great here for this little demo. Don't want it to run too long.
So I'll just continue off from where Chris left. Unfortunately, I don't have the demo. But what Chris was basically saying was in the continuous query notification, you would subscribe. You would use a publish subscriber model, and in the publish subscriber model, you would get the messages from to and from the queue. And as you can see here, once the once the queue has been set, once the query notification has been set, your messages, you will receive the messages as per the query that Chris had shown earlier, where he wanted messages only when the data value became greater than 100 or some value that he had set. Sorry, we could not show the demo more, but unfortunately Chris is out. I would like to talk about the last section of this talk, which is the continuous availability. So we will look at high availability with a focus on the application continuity feature. You can check the oracle.com portal to get more information on continuous service availability. So why do we need high availability? Well, without high availability, you will see that applications hang. If there is an outage, connection requests hang, and there will not be any automatic reconnection when the service is resumed. You will get so if there is a planned maintenance, you will receive errors. The users will see errors, and there will be slow, hung, or dead nodes, which will affect your work at some particular point. And also, there is a possibility of doing duplicate transactions. So to avoid all this, we have to ensure that the application is continuously available. So one particular example that I'm planning to take here is that is in this case when connections in the pool become unusable due to either network dropouts or DB resource limitations. So by default, network dropouts or DB outages are not detected by the connection pool. This is actually a scalability feature, the assumption being that why should we penalize the working system by doing unnecessary checks? Also, they can dispense an unusable solution. Result is when the unusable connection. The result is when you're using when the unusable connections, when you try to use them, an error occurs. So depending on your application requirements, you can implement various levels of solution to handle unusable connections. The first suggestion is to keep up to date with the Oracle client. The second suggestion is that we have a tuning setting parameter called ping interval, which you can set. But you should always keep in mind that the ping interval should not be too small, so that it pings every time and affects the DB resource and affects the other connections that are being used by for the database. The main takeaway from this slide is that you have the latest up-to-date Oracle client libraries to ensure that Oracle always detects any unusable connections due to whatever the reason may be. So another way by which you can ensure connection availability is to configure the TCP timeouts on the network configuration files like SQL.net, SQLnet.ora, and tnsnames.ora. So here you see the list of Oracle Net options that you can set for connection availability. The outbound timeout, which is the timeout interval for the client to establish connection with the DB server. The RECV timeout, which is the interval for the client to receive data from DB. You have the send timeout, which is a timeout interval to send data from the client to the DB. Another useful feature or useful option that you can use is the expire time. So this is ideally used to avoid firewall timeouts or the DBA killing idle sessions. So when you set the expire timeout here to 3, and let's say your firewall timeout is 6 seconds, so in that scenario, your expire timeout will send a keep alive message across the network, so that the firewall timeout is never actually activated. So it is always advisable to check for errors after you use the execute function, since the connection can become unusable at any time. One more tip with expire time in C clients is that with 18 C client libraries, it can be added to the description section of a connect descriptor in SQLnet.ora. With 19 C libraries, it can be used via the EC Connect host. It can be used via the EC Connect syntax that you see over here. Also, in Node, you can use the connection call timeout to set a timeout for your connections in Node Oracle DB. So here I just want to talk about the various premises where you can set high availability. So you can set high availability in the various Oracle advanced options in Rack, in Oracle Rack, in Oracle Data Guards, and Active Data Guards. So you would want to move. So the reason you need high availability is if you require a plan, if there is a planned maintenance for your database setup, or if there are unplanned outages in your database. So the technologies which will enable high availability are TAF, which is transparent application failover, fast application notification, FAN, application continuity, and transparent application continuity. So quickly talking about application continuity, it is typically used for unplanned downtime. It is a feature available in Oracle Rack, Oracle Rack 1, and also Oracle Active Data Guard. It is also available with Oracle Autonomous Database. So application continuity records the work done by client libraries to the DB, which allows the session to be recovered from a known point. So this includes session state and transactional state. The application continues as it was, seeing a slightly delayed execution time when a failover occurs. So this masks a lot of unplanned outages. So it is simple to configure application continuity with a database service setting called failover equal to transaction. And improvements are being made for each version on the application continuity. The transaction guard that you see over here for under commit outcome ensures that if a transaction is committed, then it is not replaced, so you don't have unnecessary transactions. And you also have other settings such as failover, restore, and reset state. These are the latest features which have been included in the latest versions like 19C and 21C. So how does application continuity work? Well, there are two phases. So the premise is you are using an Oracle connection pool or a session pool here. So in the normal scenario, the pool will mark a start of a request. You will you will run whatever queries you have with the pool, and at the successful end of the request, the client will purge the captured calls. But what if there is a failure? That's when the second phase of the application continuity comes in. So you will do a replay on failure, where the client libraries will check that the replay is enabled first. Then it will it will create a connection. It will verify the timeliness. It will check if the replay database is available and it's valid. And if it will also check for commits which have already been done, and it will roll back the uncommitted transactions. And now the client libraries will replay the captured calls, and then there will be a server and client will ensure that the results returned to the application match the original results. So some restrictions here. So as you can see, the replay capture will be disabled if successful commit occurs, if there are unsupported calls. So unsupported calls include objects, AQ, the advanced queuing and sequence that you saw earlier, two-phase transactions. Also some mutable functions like sysdate, systamp, timestamp, etc. And SQL can be if you want to enable replay for if you want to eliminate these restrictions, you can use SQL. Also note that there is a limit to the number of calls that can be replayed. Old limit was I think 500. Right now from April they have added a new limit of 10,000 for fetch, bind, and define calls for the replay, and 250 for statement prep calls, and 2,000 for other calls. So I want to talk about transparent application continuity, which is the latest feature. There is a user choice whether the user wants to use AC and TAC or TAC. TAC may be more conservative and tries to restore the state, so it may cause much more rejections if it cannot restore that state. So it will work for you need to set the service attribute failover type to auto as compared to the earlier failover type for application continuity. It is available from Oracle 18C. It automates some of the tasks that application continuity cannot handle. For example, it will recognize the request boundaries. For application continuity, the boundaries start from the connection pool, but for transparent for TAC, it is much more broader in that sense, and it recognizes side effects that should not be replayed, and it also recognizes basic mutables, which includes things such as sysdate or sequences for SQL, that is grants required for PL, SQL, etc. And it recognizes them as replayable, and it will replay it. So TAC will re-enable itself at a transaction boundary if disabled for a previous transaction. So some rules for the implicit boundaries is that there should be no transactions, no open cursors, no temporary logs, and no complex session state. And now with Node Oracle DB, how do you use it for TAC? You can use order by or group by, and you can set the connection.module and connection.action to enable TAC or application continuity. So to check the TAC or ACK, you can use this AC check CHCK coverage report tool. This is successor to the earlier used Aura check tool. So you use it by enabling AC or TC on the database. You can use the PLSQL package that you see over here to enable recording. You can run your app, and then you can use DBS app cont admin to get a report. So AC check is actually like the AWR, the reporting tool that we have in Oracle. You enable it, run your app, then generate a report. So it is not necessary to induce failures when you run your app. Regular runtime operation is sufficient. Again, please check out our Oracle website for the application checklist for continuous service for MA applications. And with that, I conclude my presentation. Hope everyone found it very useful. This is our contact, so you can contact us anytime. Me and Chris are always available. You also please do check out our blogs and GitHub as well to get more idea on our Node Oracle DB driver. Thank you and have a good day.
Thank you, everyone.
If you have any questions, please feel free to contact Christopher. Saying that, thank you so much, Christopher and Sharat. And please take care and be safe on these crazy times. And hopefully for next year, we can have face-to-face events again and make the life to everyone even easier. Please take care, everyone, and be safe and have a wonderful day, afternoon, or evening, wherever you are.
Thank you, Francisco. Thanks, Sharon.
Thank you. Thanks.
CloudDB, shaping your new normal.